Hi, this is Michael Pfeifer. Welcome to another episode of Metal Conversations. In this episode, I'm going to talk about hydrogen embrittlement of steel. Specifically, I'm going to talk about hydrogen embrittlement of steel fasteners, because that's the major component that we're concerned about for hydrogen embrittlement. So I'm going to discuss the basics about hydrogen embrittlement. Then I'm going to steer you to my website where I've written a recent article and made a video that goes into more details about hydrogen embrittlement. In this episode, I want to talk more about the engineering process side of preventing hydrogen embrittlement. So the basics with hydrogen embrittlement is that a metal can absorb hydrogen when it's exposed to atomic hydrogen. When the metal absorbs hydrogen, the hydrogen can diffuse to the metal's grain boundaries and then form bubbles on the grain boundaries that weaken the grain boundaries. A result of this is loss of ductility of the metal and cracking at stresses lower than the metal's yield strength when the metal is exposed to a tensile stress. And so with fasteners that are coated for corrosion resistance, then in like coating with something like zinc or nickel or chromium, then typically the coating process that's used is electroplating. And during the electroplating process, hydrogen atoms form at the surface of the metal, and or at the surface of the steel, and then that hydrogen can be absorbed by the steel and go to the grain boundaries and cause hydrogen embrittlement. So we know that the steel will form, that hydrogen will form at the surface of the steel when steel is being electroplated with a coating for corrosion resistance, and it will absorb the hydrogen. So what has to happen is that the steel has to be baked out after electroplating to give the hydrogen a chance to diffuse out of the metal. And there are specifications or standards that discuss the baking process for steel and for different coatings. If you want to learn more about the hydrogen embrittlement process and the bakeout process, go to the website, or the industrial metallurgist website, and one of the recent blogs is about hydrogen embrittlement, and there's an article and a video. In the rest of this podcast, I want to talk about the engineering process side of preventing hydrogen embrittlement. So if you're designing a fastener that will need an electroplated coating for corrosion resistance, then there has to be systems in place to help prevent hydrogen embrittlement of the steel. So the first thing is that it's important to write a good specifications on the fastener drawing. Call out the required bakeout and applicable hydrogen embrittlement bakeout standard. It might be an ASTM standard, an ISO standard, or SAE standard. And you should understand what that standard says and what the requirements of that standard. So don't just call out a standard without reading it. Understand what it says and what it requires of the person who's going to be depositing the coating. The second thing, don't trust that all electroplaters know what they're doing and have good control over their process. Verify their bakeout process. Verify that they understand and that they do indeed perform the bakeout within a few hours after the parts are coated. If too much time elapses between the coating and the bakeout, then the bakeout will be useless, because by that point, the hydrogen atoms will have diffused to the grain boundaries and the bakeout won't work. So verify that they understand what's required and that they have the process in place for meeting that requirement. This is going to require going and visiting the electroplater and verifying it, because it's the electroplater is the one that will have to be doing the bakeout. The third thing is that you can perform tests on samples when you receive samples of fasteners. There are ASTM and ISO standards that discuss the testings that can be done on fasteners to determine whether they have been embrittled due to hydrogen embrittlement. You can't just look at a fastener and tell, and you have to do the testing. And finally, it's not worth using a low-cost supplier if you're concerned about hydrogen embrittlement. It's a real bummer to find out that you have parts in the field that are starting to come apart because the fasteners you used to hold them together are failing due to hydrogen embrittlement. And it would really be not much fun to be involved with let's say a 50,000 part recall or a 200,000 part recall, because batches of fasteners are that large. You don't want to get a part returned or a product returned from a customer and find out that a fastener has failed due to hydrogen embrittlement. This is something that is avoidable. So don't use low-cost suppliers for electroplated coatings. It's just not worth it. Finally, there are some other things that can be done from an engineering perspective to prevent hydrogen embrittlement. If you need a coating that provides corrosion resistance and you want to use electroplated coatings, then another approach is to use lower strength fasteners that are not susceptible to becoming embrittled. So if the strength of the fastener is low enough, we don't have to worry about hydrogen embrittlement. Another option is to just don't use an electroplated coating. You can perhaps use a mechanical coating or some other form of applying the corrosion resistant material that will help protect from corrosion, and we don't have to worry about hydrogen embrittlement. Another approach is, if you need corrosion resistance, is to use a higher strength stainless steel. With a stainless steel, you don't have to electroplate a coating onto the stainless steel, because the stainless steel has corrosion resistance. The question is whether, though, there is a stainless steel that will be both corrosion resistant for the application and also that you can get the high strength that needed for the application. One possible option might be a precipitation hardened stainless steel that has both good corrosion resistance and high strength. Finally, does the application really require good corrosion resistance? If it's something that's being used in a confined environment that's not exposed to the atmosphere, then maybe you don't need corrosion resistance or very good corrosion resistance, and you can use some sort of coating that just provides a fair amount of corrosion resistance, which might be all that's required for the application. So that's it. Again, hydrogen embrittlement is something that we have to be concerned about for high strength fasteners. And there are things that need to be put in place from an engineering perspective to help ensure that hydrogen embrittlement will not be a problem and will not come back to haunt you when your product is out in the field. So that's it. If you have any questions or comments, please email me and let me know. My email address is mike@imetllc. Also, if you haven't already, subscribe to the Metal Conversations podcast series to receive alerts for when new podcasts are released. You can subscribe on Spotify, Google Podcasts, Apple Podcasts, and all the other usual outlets. And finally, on our website, you can subscribe to receive alerts about podcasts and courses and webinars and other articles that I write about engineering, the intersection between metallurgy, metals engineering, and product design and manufacturing. Good luck with your metals. Bye.